Hello everyone. We have already finished moment distribution method on beams. So the next is the same thing we'll be using, same method we'll be applying for columns. Okay. All right. Now here in this given problem, it is like analyze a given frame by moment distribution method. So there's a frame given here, A, B, C, D. A, B is fixed uh, frame, fixed column, and CD has in CD the D joint D is short length and has short length and it has a roller support. Okay, and there is UDL BC at BC of 30 kilometer meter. Okay, so they have asked us to analyze this given frame by moment distribution method. All right. So now we don't know whether the frame is swaying or no. Okay. So we don't know whether to apply a non-sway analysis for this or a sway analysis. Right in the case of the previous type of problems where you had solved from the first model, that is slope deflection method, just by looking at the frame, we could figure out whether it is a sway analysis. We have to apply a sway analysis or non-sway analysis just by seeing the length of the column or the type of the loading by the symmetry or the I values of the individual members. But here we cannot figure out and judge whether it is a sway analysis or non-sway analysis. In that case, what we do is we carry out both the analysis for this. May it be any type of frame. So first what we do is we are going to assume it as a non-sway frame. So we are going to assume that the frame is not swaying at all. It is not moving. Hmm? And that analysis we do. The same thing what we do. The next step is same procedure. The next step what we are going to assume it as, it is going to sway. So the first step in any analysis used in moment distribution method, which is applicable for all type of frame, is first we are going to assume it as a non-sway analysis. So we carry out non-sway analysis. That's the first step. Then the same thing we are going to assume it as a sway analysis. Okay. So in the first given problem here, first we are going, the problem, everything remains the same. Okay, so only thing what changes here is the type of analysis. You have to do two different analysis here, so non-sway as well as sway analysis. Okay, so you can see here, so in this given frame, so when you split this, you'll only see this reactions here. At A, there is only one reaction, RH. At D, there is another reaction. Okay, about this, I'll tell you later. Okay, so right now it looks like this. Only the we're going to concentrate more on the columns here. So first thing is we are going to assume it as non-sway analysis. Non-sway means it is not going to move at all. So the columns remain straight even no matter if there is a load applied here. So if it is a non-sway analysis, things would be same like what we have done before. That is finding the fixed end moments, then finding the distribution factor, finally the moment distribution table, and we are going to find the final moments here. Everything remains the same what we have done before for the moment distribution method. What you have done before, the same steps repeats. So non-sway analysis is nothing but we are going to assume that the complete frame is not moving at all. It is straight, it is rigid. Even though you applied the load, it is not going to moving at all. So so the steps are all same. So that is first thing is non-sway analysis is first find the fixed end moments. Hmm? So in this first fixed end moments, so find the, so you can see here A, B and C, D. It doesn't have any loads. Because it doesn't have any load, so fixed end moments MFAB, BA, CD and DC is going to be 0. Okay, so there is a UDL only in BC span. So MFBC is equal to minus WL square by 12 because it's UDL, so minus 90, and MFCB is plus 90. Okay, so then finding, after finding fixed moment, next is joint distribution factor. To find distribution factor, there are obviously two joints here, that is B and C. So it is like BA and BC is one, CB and CD is another. Okay. So BA. So BA is fixed support. So because it is a fixed support, so it is 4 by 4 EI by L from B to A. So it is 4 EI by L. Okay, again B to C, because C is the intermediate support. When you open this frame, so C is like the intermediate support. So again, Because it is intermediate support, we'll be treating this like a 4 ei by l, like a fixed support only. So it is 4 ei by l, and be careful to use the I values properly here, because in some case it is 2i, in the other case it is only I. Okay, next thing is this portion CB and CD. So CB, again B is the intermediate support. Because it is an intermediate support, it's treated like a fixed support, so it is 4 ei by l, 4 ei by l. And CD, okay, CD. Now D is it is having a simply support or a roller support. So that's why the formula changes to 3 ei by L. So it is 3 ei by L. So add both of this, same thing what you've done before. Add these two here, summation, these two right here. Then distribution factor is K by summation K. So K by summation K, K by summation K. Same thing apply here. Okay, so you get distribution factor, everything as such. Okay, then as usual again, so find the moment, draw the moment distribution table and find the uh, final moments here. So this is A, B, C and D. So remember A, B, B, A, B, C, C, B, C, D and D, C. Then distribution factor we have already calculated for B and C. Write this. Okay, now the fixed end moments, it is same like what you have done before. Finding the fixed end moments, balancing carrier, balancing carrier. It's repetitive. Okay, so fixed end moments is applicable only at BC support. Okay, BC support. So it is minus 90 and this is plus 90. Okay, then once you write this fixed end moments, next go on balancing it. So once you go on balancing it, so it is minus 90, change the sign into 0.5 into 0.5. Then plus 90, change the sign, minus 0.7, minus 0.43. Okay, then similarly after this carryover moment, carryover here, here, everywhere. Okay, but what happens here is it will not get carry over to this joint, because joint D is a having a roller support. That means it is a simply support. So here it will not get carry over. So at this portion it will be 0 only. Moment at this portion would be 0. Okay, so nothing gets carry over here. Okay, I've shown here, but eventually I've again struck it out, so don't use these values. So again, at from B, from BA it gets distributed to A, because A is a fixed support. So half of the moment gets distributed here, half at C, half at B. Again, why at B and C? Because B and C are the intermediate supports, and intermediate supports are nothing but the fixed support. And because it is a fixed support, half of the moment gets distributed equally here, this portion. Okay, then after this carrier, again balance the joint B and C again minus 25.65, change the sign into 0.5 into 0.5, write it here. Then 22.5, change the sign, so it becomes minus and minus, into 0.57 into 0.43, write it here. Then once you balance this, then carry over this portion, half and half, everywhere it gets good. Okay, here I've shown it here, but don't write this because I've eventually scratched it out. So because the simply support, it will not, the carryover movement does not exist there. Okay, then this portion here, okay, minus 6.412, again change the sign, plus and plus, so minus 0.5 minus 0.5, same thing here. Then again carry over again to all the joints here, which will be treated like a fixed support. Now this again balancing carrier, all this should happen until you reach at least the second decimal place should be a number. So first should be a 0, second decimal place should be a number. Yeah, like this. Okay, once you reach the second decimal place as a number, so first decimal should be a 0 and next would be a, uh number, then stop this here. So last step is balancing. So once you balance this, then write the final moments. Now it's more important for you to write this non-sway final moments, because eventually in the table we are going to sum up all of this. So in the beginning only, write this as non-sway final moments. So add all of these. So add this column, continuously go on adding the columns here. Okay, so this is the non-sway analysis, that is non-sway analysis, and these are the final moments. Okay, so this part is over now. One step, analyzing the frame, analyzing it as a non-sway, is over. And the next step is we're going to assume that there is a sway force acting. Now, that means because there is a difference in the length here, and difference in the I values here. So because this 30 kilonewton is acting here in BC, there must be some sway happening. We don't know whether it is happening to the left side of B or right side of C. That is, we don't know where the complete frame is moving, whether to the complete right side of C or left side of B. So we are going to make a sway analysis. Now we are going to assume a few things here. Let's here sway force. Now we have to find out the force which is trying to push it to the right or left. Now how do we do this? Is we are going to find the moment at the top of the columns. So when the sway happens, when the movement of the complete frame happens, the only thing what moves here is, okay, see here, the only thing what moves here, A changes to A dash. This A, it sways here. From A, it moves like this to the right. So B changes from B to B dash. D will be fixed here only. C changes to C dash. So that means it looks like this: A, B dash, C dash, and D dash. Okay, it might have swayed like this. This is one possibility. Or it can move like this: left side, A, B dash, C dash, D, like this. Okay, so now when the sway happens, only the columns are moving. If you have noticed, it is A, B or C, D, only the columns move. B will remain straight only. It will not move. It is not affected. So the only members which are affected during sway is the columns. Okay. Now because it is the columns, so what happens here is we are going to only take the moment of the columns here. Now see here, RAH is nothing but the column side, right? Okay, RAH, only this AB column. So RAH. So here there are, we're going to find two moments here. That is MAH. Okay, MAB and MBA. There are two moments only here acting. So if you want to find RH, that is nothing but MAB plus MBA. This column only. MAB plus MBA divided by total length. Okay, same thing what we have used before in slope deflection method. So RDH, if you want to find RDH, so it is MCD plus MDC divided by length of that member. Okay. So RAH is equal to, substitute the values what you have got here. You already found out all the values. You got RAH as well as RDH. So both you have got. So now sway force. Now this sway is one such force. Now you can see here in this, RAH and RDH are acting to the right side. We're going to assume that these are the movements which are going to act to the right side. Now to stop this movement, what the sway force is doing is, it is acting to the left side. So S is to the left. So now to keep it in equilibrium, what we are going to do is, S is equal to RAH plus RDH. That is, it is like this. If you use the sign convention, RAH, this is plus RAH plus RDH minus H minus S is equal to 0. So when you solve the equation, so it will be RAH plus RDH, okay, and solve this. So S is equal to minus 1.75. So this is the force. So initially we have assumed that S is acting to the left side. So whatever we have assumed is right. So the sway force, because wow, we got to know that whatever assumed is right is from the fact that S is having a negative sign. So because it has a negative sign, that means it is acting to the left side. So what we have assumed is right. So S is equal to minus 1.75. So this is the sway force, okay, acting to the left. So now in the sway analysis, what we're going to do is, okay, so this first portion is, oh, now in the sway, actual sway analysis we are going to do. Okay, now how do we do this? So let MFAB and MFBA be the fixed end moments at AB and CD respectively, and let delta be the sway. Now delta is nothing but the horizontal movement. So if this is a force, so if it is moving to the right side like this, if it is changing, so this is initial position, say this is the final position. This horizontal movement, this horizontal movement is called as delta now. Hmm? So that delta, we're going to use it here. Okay, let's see here. To find this, we have the formula that is MFAB by MFCD. We want to find how much are these forces. Now, in this way analysis, we're going to assume something because we don't know how much are the forces acting here. We just got to know that this way forces acting to the left side. Now we have to find how much is the forces acting. Now to find out this, so it is MFAB by MFCD. So it is AB by CD only is equal to, okay, this is the formula used, okay, that is 6EI delta AB, 6EI AB delta divided by LAB square, 6EI CD delta LCD square. So you can use this formula, or straight away what you can do is you can use this IAB by LAB square divided by ICD by LCD square. Directly you can use this formula because eventually the 6 e and delta will cancel out, numerator and denominator. So that's why, so we're left with IAB by LAB square, ICD by LCD square. So if you notice, so we are taking column AB first, column CD, column AB by column CD. So this is practiced for all type of problems in frames. So again, when this goes on top, so it is IAB by LAB square into LCD square divided by ICD. Hmm. Now substitute the value of IAB. So IAB is, we have got here, okay, IAB. So AB is 2I. ICD is I. Okay. Again, use the length also properly. Hmm. So this is 2I by 6 square into 3 square divided by I. So again, when you solve this and try to keep this in fractions always, there is a reason why you have to keep it in fractions or in keep you have to keep in terms of ratios, because those are the moments which you are going to take it later to solve the problem. So right now it is 1 by 2. Okay. So 1 by 2. Now this 1 and 2, you can take this as 1 kilonewton meter and MFCD as 2 kilonewton meter. But what happens is when you're finding out in the moment distribution table, so if you take 1 as the less value, when you again do balancing and carryover, so this uh, 1 kilonewton will distribute very fast and you end up with a very short steps. So to just increase the steps and get the accurate value, so what we do here is we're going to take this factor. So if it is like 1, if MAB is 1, MFCD should be double of that. So if you take this as 10 kilonewton, this will be 20. So if you take this as 100 kilonewton, this will be 200. So it is, the choice is yours. You can take as, because these are all, you're going to assume this. You don't know actually what exactly are the moments. So you're going to just assume this. That's why you need to keep it in form of ratio. So now here, in order to solve the moment distribution table, I have taken here, this is 50, MFAB is 50 kilonewton meter and MFCD is 100. So this is, again, when you multiply 50 into 2, it is 100. You have to keep this ratio as such. Okay. Or else you can keep it this as 100 and this you can keep it as 200. No problem. The choice is yours because these are just the assumed moments. And the most important thing is whenever you take this moments, it should have a negative sign in this. Though you get the ratios as positive, you have to take the fixed end moments as negatives. So it is minus and minus. So now these are the moments which we are going to use in the moment distribution table. Okay, so moment distribution table, see, distribution factor would be same because nothing is going to be changed. So what we have done before for non-SPAN analysis, the same thing here, distribution factor. This distribution factor remains same, 0 0.5, 0 0.5, 0.75, 0.57, 0.43. This would be same. Okay. Only thing is the moments changes here. Okay, same. This is same. Then fixed end moments is, okay, now you can see here. MFAB, MFAB and MFBA is minus 50, minus 50, minus 50. Then last, so the last column has again column moments, so that is minus 100, minus 100. You have to use this for both. Okay, here also. I've just shown here for AB. So this is applicable for BA also. CD, DC. Okay. After this, now you have to use here the sway analysis. Now, so you can see here, there is a moment acting, at D. Okay, but what should be done at D is that at D it is a simply support. Whatever moments is there, we have to remove those moments here. So in order to remove these moments, you can see here at D there is minus 100 kilonewton meter acting. Now this minus 100, okay, just change the sign, keep the magnitude same, change the sign. So when you change the sign, so minus becomes plus, so minus 100 becomes plus 100. Okay, now balancing at D. Now it's very important to balance D because D is a simply support. So once you balance D, now when you add this, see this complete column, when you add this eventually, so plus 100 minus 100 becomes 0. So now this joint D is balanced. Okay, once the balancing is done, next is carry over moment. So carry over. So adjacent side you have to carry over because C is a intermediate support. So because it is intermediate support, half of the moment get carry over. So 100, half of this is 50. Okay, so after this, once this 50 is here, next is you have to balance it. Okay, now how to balance this is, okay, so when we are balancing this, so it is now you have to take the complete fixed end moments at this joint, complete joint C. So in joint C, now check this. This is minus 100, okay, and this is plus 50. So minus 100 plus 50 is minus 50. So because it is minus 50 here, change the sign. So change the sign, it becomes plus. So plus and plus here into 0.57 into 0.43. Okay, so write this. Similarly, come to joint B now. So in joint B, check the fixed end moments here. So it is minus 50. Again, change the sign. So it is plus. So it is plus into plus 50. So into 0.5 into 0.5. It's plus 25, 25. Okay. Next, after it is balanced, next is carryover moment. Carryover moment. So it is half here, half of this, carryover here and here because at A it is a fixed support. Similarly, once this half and half gets carry over, so next is again balancing here. So balancing here is 14.25 into, again change the sign, minus and minus, into 0.5 into 0.5. Same thing here also. Again 12.5, change the sign, minus and minus. So 0.57, 0.43. Go on doing this. Again same thing, carry over, half of this carry over moment, then balance, carry over, balance. Okay, and always be careful with the signs because most of the time whenever we're whenever we carry over here and then we try to balance it, we tend to forget the signs here. So be very careful. If it is plus, you have to change the sign into minus. If it is minus, you have to change the sign into signs into plus. So that is the thing, you have to be careful. The same thing you have to go on repeating. Okay, same thing you have to go on repeating here. Until when? Until you reach the point wherein the balancing, you can see it. Now you have reached the point wherein at this point it is the second decimal place is 0. Here the second decimal place, here the third, second decimal place 0. Here it is the second decimal place is 1. Okay, so this is the time you have to stop. So once you stop this, next is after balancing, then write the final moments here. Okay, fine, go on adding all of these. Okay, this and the check for you all, whatever you did is right or wrong. See here, if you miss one sign from plus to minus, minus to plus, the complete problem goes wrong here, and that you'll get to know only at the last step, that is here. If this is a plus, if this is minus, this should be plus. If this is plus, this should be minus. So at the joints, the movement should be equal and opposite. Okay, okay, now these are the movements which are called as sway movements, and these are called as assumed sway moments. So we have got non-sway moments and we have got assumed sway moments. Okay, next is the final calculation. Okay, so the final calculation here is, okay, you can check it out here. First thing is what you've written here is this should, the table should be like this only, final moment calculation. So assumed sway is sway analysis 40, 30, okay, 40, 30, all these things you have to go on writing with the signs. Okay. Next is the actual sway. Now, how to calculate this actual sway is, you can see here. To find this actual sway, we have got these values, but actual sway is, there's a formula to calculate the actual sway. So, actual sway is nothing but assumed sway into the correction factor. There's something called as correction factor. Now, how to calculate this correction factor is, see here, now the assumed sway force, we are going to assume it as, you can see here, RH you have put, RDH you have put, you have to put S value. The S is, initially we had got it 1.75, which is acting to the left. Now, what we are going to assume that S dash is the assumed sway force. This S is the original sway force. Now S dash is the assumed sway force. Now we are going to assume that maybe it could be to the right side also. So initially we are assuming to the left. So it could be to the right side. So what I'm showing here is S dash is going to act to the right. Now if it is acting to the right, so there's again the same formula is applied here. S dash, S dash, it is plus, okay, S dash plus, again RAH plus RDH, RAH plus RDH, they are going to act to the right side only, is equal to 0. So S dash is equal to, solve this. We've already got this, right? We've already got this in the sway force. That is this 40.38 plus 30 point this thing. The same forces here. Then in RDH, we've got only one, that is 32.17. Okay, divided by 3. So apply this formula equal to 0. So solve this. So S dash is equal to, so it is 22.75. So S dash is 22.75. So the answer is positive. So what's happening here is S dash is positive. So initially we have assumed it to be to the right side, and answer what you have got is also to the right side. So what you have assumed is right. So now we'll apply the correction factor. So now the correction factor here is, okay, don't consider the sign here. The signs are ignored. Okay, so correction factor is nothing but S divided by S dash. This is the formula. K is equal to S by S dash. So S is initially what we have assumed, that is 1.75. S dash is what we have got now, 22.75. So S is the, during the non-sway analysis what we have done, S dash is the assumed sway analysis. Okay. So once you divide this, you'll get one answer. So answer is, don't take the signs here. So I've ignored the signs here. So I've taken it plus. So 1.75 divided by 22.75. It is 0.077. Now this is the factor. Okay. So assumed sway analysis is what you have got here, 40.38. Okay, follow this table like this only. Ultimately, what we're going to do is actual sway plus non-sway. Give us the final moments. So assumed sway is 40.38. Okay, 30.75. We have used this. Write this here. Okay, actual sway is K into assumed sway. Okay, actual sway force or the sway moments is assumed sway at that particular member, at that particular joint, into the correction factor. Okay, we are using the correction factor here. Now this correction factor is nothing but, in order to keep the frame in an equilibrium, and to maintain all the movements, we are applying this correction factor at this portion here. So it is 40.38 into 0.077 is 3.11. Similarly, um, okay, again be careful with the signs here. I've just taken the sign different here. You can use this here only. Okay, so actual sway is 3.11. Next, 30.75 into 0.077 is minus 2.36. Same thing here, 30.75 into uh, 0.77 is 2.36. So apply this. Okay, so this is the actual sway force. So you can just highlight this box. Then non-sway analysis, in non-sway analysis, we've already got the non-sway movements here. Initially, what we have done. Okay, so this values you have to take now, non-sway. Okay, this is a non-sway analysis. Okay, so this is a non-sway analysis, write all this. So then is, in the end, if you want to find the final moments is nothing but actual moments divided actual moments plus non-sway moments. Same, add, go on adding 3.11 plus 31, 2.36 plus 62, minus 2.36 minus 62. Okay, so go on adding this. So when you go on adding this, you'll get the right answer. So these are the final moments which you got when you've used, whether it is a sway analysis or non-sway analysis, applied the correction factor, and this is what you get in the end. That is the final moments. So till here you have to solve the problems. So again, these problems are little lengthy, but they are quite simple unless and until you understand the concept. So first thing is you're going to make it a non-sway analysis. Next is you're going to solve it by making a sway analysis. So in sway analysis, you're going to decide whether it is going to the right or it is going to the left. So again, if you don't know whether it's going to the right or left, apply the correction factor. So with that correction factor, apply it here. Then you'll get the actual sway moments, then add the actual sway moments with the non-sway moments, you'll get the final moments here. Okay. All right. That's all for today. Thank you.